Hello and welcome to podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, or add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, and please give us feedback. You can leave a review on iTunes to help other people find the show, send us a tweet, send us an email, leave us a message on Google+. We are also running a listener survey to get feedback about the show. You can find it at bit.do/podcastinit-survey with a link in the show notes. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. And I would also like to thank Hired, a job marketplace for developers and designers, for sponsoring this episode of podcast.init. Use the link hired.com/podcastinit to double your signing bonus to $4,000. Your hosts as usual are Tobias, Macey, and Patti. We recently launched a new discourse forum for the show, which you can find at discourse.pythonpodcast.com. Join us to discuss the show, the episodes, and ideas for future interviews. Today we are interviewing Ben Darnell about his work on Tornado. Ben, could you please introduce yourself?
Yeah. Hi, my name is Ben Darnell. I'm the maintainer of the Tornado library for Python. And in my day job, I'm the co-founder of Cockroach Labs, where we're building a new distributed database that's open source in Go.
I've heard about that. It's definitely one that's been pretty interesting and one that I'm keeping on my radar. So I didn't realize that you were working on that as well.
Yep.
So Ben, how did you get introduced to Python?
So I don't remember how exactly I first discovered Python, but it was very early in my programming education, and I was trying to make the leap from BASIC and Pascal to C, and was kind of struggling with it. And I learned about Python and tried it out, and really appreciated the fact that it was so introspectable that you could open up any object and look in and see the dictionary attribute on every object and kind of see how it works that way. And then I had some trouble building some C extension, and that gave me an occasion to go and dive into the Python interpreter source code and extension library interface. And that was when a lot of things kind of fell into place for me about how developer tools, which I had thought were this kind of unimaginably complex software, could all be assembled out of individually understandable components. And so that was it's kind of a turning point in my understanding of programming, and part of the reason that I've had a soft spot for Python ever since then.
So, what is Tornado, and what sets it apart from other HTTP servers?
So Tornado is several things. It's a web framework and a server and asynchronous networking stack that all work together. And so using the entire stack together, you can make asynchronous web applications which can very efficiently serve lots of connections to users that are just held open and able to serve real-time updates out to the web pages. So it was originally developed at FriendFeed, which was a social network that was acquired by Facebook in 2009, to power the real-time updates on the web page for new posts and comments.
And how did you get involved with Tornado?
So I joined FriendFeed actually shortly before the acquisition by Facebook, and so I wasn't around for the original writing of the Tornado code. I was there when the decision was made to open source it, which happened shortly after the Facebook acquisition. And so we basically went through the FriendFeed code base and found all of the things that looked generally useful, and pulled those out and made an open source library out of them. And then maybe a year later, in 2010, I was at another startup called Brizzly, and we were using Tornado, and the FriendFeed team at that time had moved on to other things, and so they weren't doing anything with Tornado at the time. And so I picked it up and started making contributions back to it for what we needed for Brizzly, and ended up basically really enjoying that kind of open source work on the side, and adopted the project and have been maintaining it ever since.
So that extraction from an existing code base seems to be somewhat of a popular method for the progeny of various open source projects. I'm curious if you can give a little more flavor of the overall process that was involved with that and some of the challenges that you had to deal with in that process.
Yeah, so some parts of the system were able to be moved more or less directly, like the I/O loop, and a lot of the core code was able to translate pretty easily. Other things were more pick and choose which parts we wanted to include. Like the web module was kind of an incomplete copy of some things that were used internally. One thing that I think we could have done better in the initial open sourcing of the project was in potentially even doing it as multiple projects. Because what we realized in retrospect is that we had a bunch of things that were only loosely related. Things like the options module and the database module were not really connected to anything else in the framework, and ended up not being very cohesive with the rest of it. And so I think those might have been better off as a separate package, and maybe also even splitting up some of the core stuff, like splitting the web framework off from the lower level I/O loop. I think we ended up keeping it all as one big package, largely because of the relative immaturity of the Python packaging ecosystem at the time. None of us knew anything about how to manage an open source package at the time and how to manage dependencies. Pip and PyPy were not as well established back then as they've become since then, and so I've certainly learned a lot about how to package things, and would have done that differently if I was starting over.
And have you considered actually going back and separating out some of the different components of Tornado into their own packages now, or would it just be too much of a burden to people who are already using the project?
So I have actually moved one module out. The tornado.database module is now a separate package called torndb, and that was because it was not only weakly integrated with the rest of the package, but it was almost a contradiction with some of the goals of the rest of the package, because it was a synchronous database layer, and it was just a very thin wrapper around MySQLDB. It didn't support any other databases, and it only added a few things on top of MySQL. And so it was one of those things where we could either invest a ton of time into it and make it into a proper database layer, or it was best to de-emphasize it and let you use whatever other database layer you wanted. And so that was the direction that we chose. And so that part's been moved out into a separate module. Everything else is still in one package, and I think it doesn't really make sense to try and split it up any further at this point, given the backwards compatibility concerns.
Mm-hmm. And what was the inspiration for the name?
The name that just came out of a short brainstorming session when we decided to open source it. It was one of the things that was emphasized originally in the open sourcing of Tornado was its speed relative to other Python web frameworks, and so we wanted a name that implied speed. It was also a little bit of a poke at Twisted. Mm-hmm. Which is, of course, the other big asynchronous framework which predated Tornado. But it was mainly we just threw a bunch of names out there, did some Googling to see what was available, and Tornado was the one that stuck.
And you mentioned the Twisted library as another asynchronous networking stack, and I know that Tornado was created before some of the recent hype on asynchronous applications, particularly after Node.js hit the scene. So I'm curious what prompted the design choice of using non-blocking and asynchronous I/O, and when might someone care about using async in their development?
So asynchronous programming on the server side really came out of two things. One is that because of the GIL, Python doesn't have very good support for multi-threading, and so you end up running lots of processes on a multi-core server in order to make use of all of those cores. And so the synchronization primitives that you get with the threading module and other thread-based libraries don't really apply in a multi-process world as well. And so if you run multiple processes, each of which having multiple threads, then you end up having to manage this kind of 2 layers of synchronization complexity. And so if you run a single-threaded event loop in each of your processes, then you can simplify, because then you don't need to worry about any sort of shared memory concurrency issues that come up with threads, because you only have one thread at a time per address space, and then so that really simplifies the implementation and the concurrency concerns. And then compared to just running a bunch of threads and processes, asynchronous systems are much more efficient at handling these tasks that are sort of at rest. So when a user has a connection to a web page and is waiting for updates, you don't want that to be a very expensive object. And in a threaded system, threads tend to have a fairly significant amount of overhead, and so by using asynchronous callbacks for these idle connections, you're able to serve a lot more connections a lot more efficiently than you would with threads.
And I know that in some of the different asynchronous networking libraries, one of the issues that comes up occasionally is what's lovingly referred to as callback hell. So I'm curious if Tornado offers any syntax to help alleviate that pain.
Yes, we do. Well, we don't offer the syntax. Python offers the syntax, but we've supported coroutines ever since Tornado 3.0 as our preferred solution to avoiding callback hell. And what this means is that you can have a function that looks more or less like a regular function, but uses the yield keyword in older versions of Python or the await keyword in Python 3.5 to indicate a point where it gets suspended while it waits for something else to complete. And so each of these points where there's a yield in your coroutine is really it's essentially a kind of syntactic sugar for creating a callback and then passing that back onto the event loop. And so you can get all the benefits of callbacks in terms of their relative efficiency and explicit context switching, while still without having to completely turn your code inside out and write have everything look kind of like it's going back to front when you have lots of nested callbacks.
So what is involved in creating an event loop, and what are some of the specific design decisions that you made when implementing one for Tornado?
So an event loop at its core is wrapping around some system provided by some service provided by the operating system to let you know when there is activity on your network connections, or potentially other things like pipes and timers and things like that. And so at its core, you're wrapping around on Unix. You're talking about one of the system calls in that Python exposes in the select module. There's select, poll, epoll, and kq are the ones, the major ones on the platforms that Tornado supports. And there's some subtleties between these different libraries, but they're all pretty much the same. Epoll and kq are the newest and fastest where they are available, and Tornado always uses of the various options that uses the best one that it can find that it supports. But all of these system calls on the Unix side have something in common, in that they're what's known as a readiness-based event loop. This is where you have a callback that, you have a system call that tells you of these connections that I'm interested in, which ones would have new data if I tried to read from them right now. And so it turns out that one of the most fundamental design decisions you make in an I/O loop, which we didn't even really realize was a decision when we made it, is whether you embrace that design where you have your the event loop, which tells higher level code that a connection is ready, and then you have that higher level code read from it, or whether the event loop does the reading and then just passes the data off to the higher level code. And this turns out to be a tremendously important decision because on Windows, Windows doesn't use a readiness-based event loop. It uses a what's called a proactive instead of a reactive event loop. In Windows, the operating system actually does the read and then comes back to you with the data. And this it turns out to be very complicated to support both styles at once. In both Twisted and Async IO, if you look at the event loop documentation, there are a lot of methods on there. There's listen TCP and connect TCP and listen UDP and send UDP fragment and all these things where the event loop has to know about lots of different things. It has to know about every different kind of connection that it may be asked to deal with. Whereas on the Tornado side, the event loop API is much smaller. You have basically listen for reads, listen for writes, and cancel a previous listen. And that's because in the readiness-based abstraction, all the event loop really needs to know about is file descriptors, and it can treat these file descriptors as a black box. And so this turns out to be why Tornado doesn't have good support for Windows, and probably never will, because we made this decision very early on that our API was going to be so close to the Unix readiness-based API that it would be a major change to ever switch over to something that could support both the Windows model and the Unix model. And this is something that when I realized that this was the consequence of the choice that we had made, that I kind of looked at that and thought about it for a long time, trying to figure out whether I wanted to try and make the changes that would be necessary to support Windows. And then I realized that actually the simplicity that you get from only supporting a single model, I actually really like that. And that's actually a big part of, when I'm working with Tornado, that's actually a big part of what I like about the Tornado event loop in comparison to the Twisted and Async IO ones is the simplicity of that interface. And so I've personally come to the conclusion that I'd rather have that simplicity than the broader platform support. Since I work on Unix platforms and don't really anticipate a great need for Windows support in my personal development, and so that's kind of a niche that Tornado has found itself fitting into. That it's relatively Unix specific in comparison to the other asynchronous frameworks that are out there.
And extending this conversation a little bit, I'm just curious how the Tornado event loop compares to those in other packages such as Twisted or the Async IO module. I know you said that the API surface is a bit smaller. I'm just wondering if there are any other specifics that you can share.
The differences in the APIs, the amount of API surface area is definitely the big difference. I think that all event loops are pretty similar under the covers. There's really very little practical difference between them, aside from the API that it enables the Windows support. I think that the one feature that Tornado has that I know Async IO doesn't, and I don't think Twisted does, is the ability to use the signal.setItimer system call to set an alarm to alert you if you have a blocking function that goes too long. I've found this really helpful in debugging, and I've been meaning to get a version of this added to Async IO upstream. Because that's the one thing that I really find useful in the Tornado event loop that I would miss if I switched over to the Async IO event loop. Also, on the subject of the differences between the three event loops, they're actually so small that within Tornado there are implementations of one library's event loop on top of the other. On top of another, and so you can run Tornado on the Twisted event loop, or Twisted on the Tornado event loop, or Tornado on the Async IO event loop. And so they're all these libraries are equivalent in terms of the amount of power that they expose.
And do they have any significant differences in terms of performance, or are they all pretty similar because they're relying on the underlying system calls?
They're all pretty similar. It's ultimately just coming down to the underlying system calls. I haven't done a lot of direct performance comparisons across them, but I would be surprised if there were very large performance differences between the different event loops. Now, when you're using the different sort of cross event loop interfaces that I just mentioned, where you're running one event loop on top of another, that layer of indirection does have a bit of a performance penalty. But just running each event loop in isolation, I think they're all pretty similar.
And earlier you mentioned the web module, and it appears to provide a minimal framework for developing web apps. I'm curious how scalable those capabilities are, and if there's a recommended architecture for people using Tornado to develop web applications, or if it's more of a architected however you see fit kind of thing.
Yeah, it's definitely an architected however you see fit kind of thing, which is both good and bad. If you're the do-it-yourself type, then you're probably going to enjoy that. If you're someone who likes a little more hand-holding and kind of the opinionated structure that you get with a framework like Django, then then you probably won't like Tornado as much. But what I've found is that for the applications that I've worked on that use Tornado, each project ends up extending the base web framework in slightly different ways, and so in that respect, I find it very valuable to keep the core web module as reasonably small as possible, and only add stuff to it when there's something that's clearly common and reusable. And then you can keep the core small so that it's easier to extend in whatever direction a particular project needs.
What are some use cases in which a developer might choose Tornado over other similar options?
So I think depending on what you mean by other similar options, I think the biggest draw that brings people to Tornado as far as use cases go is just anything involving a real-time website where you want to push updates out to the user's browser, whether that's with WebSockets or long polling or server sent events. Any of these features is going to be something that where you're going to want an asynchronous component in your system to manage all of those idle connections. But even if you don't use that, Tornado is one of the ways in which you can use the Tornado web framework is on Google App Engine, which is a restricted environment where none of this asynchronous stuff works. But you can still use the web framework in isolation, and you're not getting the asynchronous features, but you still have that same small core that I was talking about that you can then extend however you want. And so if you are someone who prefers that kind of do-it-yourself development where you can you organize the project however you like, then this may be a framework that you would choose even without the asynchronous components.
I see. So as opposed to something like Django or even something like that which imposes a fair bit of structure, if you take the concurrency out, Tornado is still a fairly compelling minimal skeletal framework to build on.
Right. It would be, if you're not using the asynchronous features, then it would be kind of in the same category as Flask and other lightweight frameworks, as opposed to something heavier and opinionated like Django.
So, speaking of concurrency, could you please give our listeners an overview of Tornado's concurrency options, including coroutines?
Sure. So, broadly speaking, Tornado supports two different styles of concurrency. The first and oldest is callbacks. This is where you pass function objects around to so that you write lots of different functions, and whenever you do an asynchronous call, you pass a callback or a closure or continuation into that function, so that you can pick things up in a new callback with the results of your asynchronous computation, and that is that's kind of the classic way to do this. This is seen all over the place, especially nowadays in JavaScript, and it's really kind of painful to work with. And so when Tornado was first developed, that's how it worked, and it worked up to a point, but it was really irritating to take a function that was run, one large function, and you needed to insert an asynchronous operation in the middle of it, and suddenly you had to cut it up into two functions and make sure that you passed all of your variables between them, and make sure that everything was being passed along in the right way. And you'd have to create more complicated structures to do two things in parallel and then rejoin them later, and it was so just generally irritating to work with. And then I saw I believe I first saw this technique used in a package called Monocle, where you could use the Python generators to implement coroutines. This idea was also fleshed out by David Beasley in several of his presentations that he gave at PyCon. And so I started implementing a coroutine framework for Tornado. This is what is today in the tornado.gen module, and this makes it possible to use coroutines, which are a special kind of function which is asynchronous but looks like a normal function in that things are executed from top to bottom in the normal way, and you can have you can have for loops and if statements and try catch, and everything just works the way you would expect. And so this has become really, I think, the core focus of Tornado and the sort of the Tornado style of doing things. Everything that I write almost everything that I write these days in Tornado is using coroutines and not explicitly passing callbacks around, because it really helps organize the code in the way that you think about it, and makes it much more tractable to do refactorings in the same way that you would any other way, while still preserving all the benefits of asynchronous code and keeping all of the switch points explicit.
And going back a bit to what you were saying about how Tornado is sort of similar in capabilities to Flask, I know that one of the common problems with dealing with an asynchronous framework is the database, because sometimes the database libraries are blocking, and so it sort of defeats the purpose of having all of the asynchronous capability on top of that. So I'm wondering if there are any libraries that you're aware of, or any that go along with Tornado for handling that sort of situation.
So there are. For example, there's Momoko is an asynchronous Postgres driver. There are several asynchronous Redis driver. There's a whole list of these. If you go to tornadoweb.org and click on links, that takes you to our wiki page where we track a lot of these libraries. But I want to go back to what you said about how synchronous access to the database defeats the purpose of an asynchronous framework. And I would actually say that it doesn't defeat the purpose. Remember when FriendFeed first developed Tornado, they were using a synchronous database driver. And so they still got enough value out of the asynchronous model to build the framework, even though they were also using it with a synchronous database driver. And I think the trick is that when you have a database that's under your control and you can tune all of the queries, if you have a query that's slow, then you're really going to ruin your performance if you do it in a synchronous database library on an asynchronous server, because that's going to block the thread. But what you really want is for all of the queries that you're doing frequently to be very fast. And if you're doing if you're doing a memcache call, for example, memcached is incredibly fast. And if you're on a local network, then you can get a response back from memcache in less than a millisecond. And when you think about how much extra computation has to go on in the Python process for making an asynchronous call, because it has to go through lots of function calls and unwind the stack and go back to the event loop and make the event loop calls, and then come back into your callback, that actually adds quite a bit of overhead. And so, for example, for something as fast as Memcache, I would say that it's almost counterproductive to use an asynchronous library, even with Tornado, because it has this extra overhead. Now, it's not entirely counterproductive, because what you are gaining is you're greatly improving the worst case behavior of the system. So nowadays, now that we have coroutines and it's easier to use asynchronous operations everywhere, I would say go ahead and use the asynchronous drivers. But originally, in the days of manual callbacks, I would actually say that in a lot of cases, you're better off just tuning your queries and making sure those go fast than paying the complexity cost of threading asynchronous callbacks throughout all of your code.
The extra overhead isn't something I really considered initially, so I can definitely see how, for particularly instances where as you said, the response comes back very quickly, it would be counterproductive to use an asynchronous library, and so it would be more useful to use in cases where you are doing expensive queries or queries over a non-local network. So, for instance, if you're using maybe a hosted Mongo instance or something like that. And you mentioned the Momoko driver for Postgres. I'm curious if that's something that you could plug in for use alongside SQL Alchemy, or if that would necessitate a different type of ORM.
No, unfortunately, because asynchronousness is it's kind of contagious. Anything that touches asynchronous code also needs to be asynchronous, and so SQL Alchemy is entirely synchronous, and so you can't really do anything asynchronous with SQL Alchemy. You would need a separate ORM. You would either need an entirely separate ORM designed from the ground up to be asynchronous, or there may be some way to kind of slice into SQL Alchemy at the right point to make it asynchronous. I'm not sure what exactly that would look like. I'm not familiar with SQL Alchemy's internals. Although there is another technique you can use, which is very clever. This was introduced by Jesse Davis at MongoDB in his motor driver, which is an asynchronous driver for MongoDB, which uses greenlets to take the synchronous PyMongo driver and make it asynchronous. And so this is a little bit magic. I'm going to go into a little bit of technical detail here to explain how that works. But with greenlets, first I should explain what greenlets are. They're a way of they're kind of a hybrid of threads and asynchronous programming. The code that you write is still synchronous. There's no callbacks. There's no coroutines. But instead of blocking a thread when you want to wait for network I/O, it actually the greenlet code kind of steps in and swaps out the stack for another stack, and then passes the network I/O that you were going to do back to an event loop. And so it's a way of getting a lot of the performance characteristics of asynchronous programming and event loops, while still maintaining a much higher level of compatibility with existing code, and you end up with something that still looks synchronous at the end of the day. And so this turned out to be a way that you could plug an asynchronous operation in the middle of the PyMongo driver without having to spread that asynchronousness out throughout the entire code base. And that has actually turned out to work very well. I was pleasantly surprised by that. I've been leery of greenlets in the past because of vague compatibility concerns and concerns about blocking without realizing it, or task switching without realizing it. But in this case, at least, it worked out pretty well. And so maybe a similar technique could be used with SQL Alchemy.
Yeah, that would be interesting to see how somebody would approach that, and if anybody does do it, I would be happy to hear about it. So I see that Tornado supports interoperability with the WSGI protocol, and one of the use cases mentioned in the documentation is for running a Django application alongside a Tornado app. And I'm wondering if that's a common way for providing WebSocket capabilities alongside an existing app that predates Tornado or was written before the need for WebSockets was realized in the application context.
Yeah, I think judging by the number of Stack Overflow questions that mention it, it does seem to be a pretty common technique, or at least a common desire. I think, unfortunately, it doesn't always work out very well because it runs your Django application on the Tornado I/O loop and blocks the whole thing for the duration of your Django request processing or your Flask or whatever your WSGI framework is. And so it effectively makes that everything you do there is synchronous, and it blocks the event loop, and so that can really limit your concurrency. It's you can certainly do it. A lot of websites don't have extreme needs for concurrency and can get by with something like this. And it's also useful as kind of a transitional strategy. This is the one time that I've done this Django and Tornado in the same process. Was at Brisley when we wanted to take our existing Django app and port it over to Tornado completely and replace all of the Django bits. And by running them in the same process, we were able to do this in kind of a piecemeal fashion. But the WSGI module actually has, I think, is more interesting in the other direction, where you want to take an app that is primarily Tornado and run a small WSGI app inside of that. I've used this a few times in the past for things like the Dowser memory profiling library and the tracing framework that's built into the App Engine SDK. Both of these packages give you a little WSGI app that you can run on your own server to give you access to your memory usage and performance information. And so I've used the Tornado WSGI adapter to embed these little WSGI apps inside my Tornado apps.
So I noticed that Tornado provides non-blocking versions of bare sockets and TCP connections, and I'm wondering if there are any add-on packages available to simplify the use of various network protocols along the lines of what Twisted offers.
Yeah, so we don't include any of these in Tornado itself, and we don't really intend to. I think it's best I'd rather have an ecosystem of different packages all implementing different protocols than to have everything sucked into one giant package like Twisted does with theirs. But yeah, like I mentioned earlier, you can go to tornadoweb.org. There's a link there titled Links, which takes you to a wiki page that lists dozens of libraries implementing various protocols on top of the Tornado stack.
Yeah, I can definitely see the case for keeping the core library smaller and letting people pull in exactly what they need rather than necessarily having all of the different protocols included by default and inflating the overall package size. Though I can also see the case for Twisted where having everything included would potentially make it easier for adding interoperability at points where you didn't necessarily know that you needed it, and just being able to easily call out to a different portion. And also with having the external modules, there's the potential for more disparate API styles, whereas if it's all included in one library, it's generally going to be a little more unified.
Yeah, definitely, and especially when you consider that when Twisted was originally being developed, again, the Python packaging ecosystem wasn't as mature as it is now. It was a lot harder to find and install and manage all of your packages. So I can definitely see why in the early days of Twisted why they went with this kind of monolithic approach.
I also think another advantage to breaking it up the way Tornado has is that, as just for instance, I mean, I think that's one reason why Twisted is still sort of languishing in the Python 2, not quite yet Python 3 category, just because there's simply so much of it to port. And Tornado, being smaller and more concise, probably had an easier job. This dovetails with the later question, moving over to Python 3. Yeah,
so, I mean, when you think about Twisted and Python 3 support, they're actually making very good progress on that. The tricky thing is just that because Twisted is so large that when they can't say that it's done because there are still lots of parts of Twisted that are not running on Python 3, but large parts of it do. And so when is it when is it going to be enough for your application? That's that's something that everyone kind of has to try for themselves and see what they need. And so, yeah, the fact that Tornado has a clearly defined boundary about it, that has certainly helped clarify what's Python 3 and what's not.
So speaking of the transition to Python 3, please tell us about the transition of Tornado to Python 3. What obstacles did you face and how did you overcome them?
Let's see. Well, the first obstacle I faced is that Tornado had very little in the way of unit tests or any kind of tests when I started the move to Python 3. So because it's basically impossible to successfully port to Python from Python 2 to Python 3 without a good test suite. That was the first thing I had to do. Was just get in there and test everything, even things that you wouldn't necessarily think about testing normally, but you really have to make sure that you cover every code path so that you can see that you're not mixing strings and bytes inappropriately. I think, but once I got that out of the way, the next big hurdle was just that I think Tornado falls into the category of software that is really among the most difficult to port to Python 3, in the sense that it has APIs that it exposes to the application developer that are mostly expressed in terms of characters and Unicode strings, but then it deals on the wire with byte strings, and so you have to deal with both kinds of data all over the place, and I found that the 2 to 3 tool to do the automated refactoring from Python 2 to Python 3 wasn't a whole lot of help in doing this for Tornado, because the output of 2 to 3 is very heavily biased towards thinking that anywhere you used a plain string in Python 2, you meant a Unicode string, and so it turns your plain strings, which were byte strings in Python 2, it turns them into Unicode strings in Python 3. So it took a lot of work to go through and annotate everything that I wanted to treat as a byte string, so that it would actually stay a byte string after 2 to 3 got through with it. And that this also it turns out because the B string syntax wasn't introduced until Python 2.6. The job of supporting both Python 2 and 3 for Tornado got a lot easier once we dropped support for Python 2.5 and we're just 2.6 plus. So we had some growing pains just on account of the amount of history that we were trying to cover and how much which Python versions we were trying to support. I'm
sure. Just out of curiosity, I know you mentioned that there were a number of things that you really had to up your game in terms of your test suite. Can you think of, if you can't, obviously it's no problem at all, but can you think of an example of a code path that you might have skipped over but that turned out to be really useful to test in the transition to Python 3?
The thing that comes to mind when I think about something that I had to test that I wouldn't have necessarily thought about is we have this HTTP request object, which has maybe a dozen different fields on it. There's a headers dictionary, there's the URL, the path, cookies, things like that. And all of these things are strings, and we want those to be just plain strings on either version of Python. So that means that on Python 3 these are going to be Unicode strings and not byte strings, because Python 3 makes byte strings a bit of a pain to work with. And on Python 2 we usually want those to be byte strings rather than Unicode strings, because because introducing Unicode strings on Python 2 can be its own kind of headache. So I ended up having to write a test case that takes one of these HTTP request objects off the wire, and then it just does like an assert is instance on every one of those fields to make sure that it's the right type of string.
Gotcha. That makes a lot of sense.
And did you find that you had to do any sort of internal re-architecting in order to support Python 3 or to perform that transition?
No, there weren't any big structural changes. The big changes were just the fact that, like I said, having to go and mark up every string as either a byte string or a Unicode string. So there were small changes that were repeated in many places, and there were some functions that just needed to be completely rewritten. There's a handful of things in the Tornado code base where I just throw out my hands and say, if sys.version is greater than 3, then def foo this thing, and if not, define it this other way. But for the most part, once I sort of figured out the right style for working in the common subset of the two languages, it didn't require any changes that were individually large. It was just an accumulation of tons of small changes everywhere.
So, based on your issue tracker, it looks like HTTP2 support is definitely on the roadmap. Could you please detail your future plans in this area?
Sure. So, as a case in point for our earlier discussion about keeping the core small and doing things in separate packages, the HTTP2 server is actually being developed in a separate package. And I've spent some time over the holidays working on it. And just yesterday, I kind of sent out the first announcement that this is basically ready for people to start playing with and seeing how it works for them. So I think that HTTP2 is very interesting for a framework like Tornado. I think that there are some features in the protocol that make it well suited for an asynchronous framework, like the fact that it's built around these long-lived multiplex connections. And so, like to implement HTTP2, you're already moving away from the thread per connection that you might use in a naive HTTP1 server. And so, in that respect, I think Tornado is a good fit for HTTP2. Also, at the application level, there are some interesting things that you can do, like push promise, which is a way for the server to push a file out to the client that the client hasn't asked for yet, and this can potentially reduce a lot of the hoops that people jump through today to kind of bundle up all their JavaScript and CSS files and sprite their images and things like that. It lets you push the data that the client needs out without waiting for the request to come in. And this is something that because Tornado is operating across the full stack from the network right up to the application, it's going to be easier for me to add push promise support to Tornado than it would be for, say, WSGI servers and frameworks to support plumbing all the necessary push promise machinery through the various layers of the stack.
Yeah, I know that there's a bit of growing pain going on right now with people trying to figure out how to adapt or create a new WSGI protocol to support HTTP2, since the current protocol is fully mired in the HTTP1 spec and doesn't really support a lot of the capabilities that the new HTTP2 protocol is adding in.
Yeah, and then that's also related to the whole introduction of async IO and the Python 3.5 async and await keywords. These are things that you can't really use in WSGI effectively as the protocol stands today. But it would be that would be something that would be good to get into a future version of the WSGI protocol.
Yeah, definitely. We've actually had other guests on our show talk about the difficulties inherent in retrofitting something like WSGI, which I believe, Tobias, maybe you have a better memory than I do. I could swear maybe it was the UWSGI folks or, I can't remember. Somebody was basically saying that WSGI as currently defined is kind of tied to the HTTP, request response lifecycle. And so it's going to be quite a bit of work to get it up to HTTP2 spec.
HTTP2 doesn't really change things all that much. It's still fundamentally request response. It has basically the same semantics as HTTP1. It's really just a few things that were introduced, like the push promise. That's the only thing that really deviates from HTTP1. I think that the issues that I was thinking of for WSGI, where you have the inability to support things like async IO, that's actually equally a problem for HTTP1 and HTTP2.
Yeah, and also the difference between going from a string-oriented to a byte-oriented protocol between HTTP1 and HTTP2. So what are some of the common gotchas for people who are just starting to use Tornado?
I think by far the biggest gotcha is just the mental leap that it takes to understand blocking and non-blocking interfaces, and essentially what it means to be asynchronous. Because I think that people hear about Tornado, they hear that it's efficient and fast and good at serving lots of connections, and then the first thing they do is they write a little test app that has a handler that has time.sleep in it, and they're like, oh, this isn't handling multiple connections at all the way I thought it would. That's just something that I don't know. I guess we haven't done a great job of explaining. It's a pretty big thing to get your head around when you're first exposed to it. But just figuring out what it means to be asynchronous and how to apply that throughout an application is a pretty big hurdle for people to get past.
Yeah, and are there any utilities that you're aware of to help with debugging asynchronous code? Because I'm sure that can contribute to some of the confusion and difficulties of people just getting started.
I'm not aware of anything. I'm actually not much of a debugger user myself. I tend to debug with print statements more often than not, and so that works just fine in an asynchronous environment. But most debuggers do have some difficulties with asynchronous code. Although I think that the Python 3.5 async and await statements, because it embeds a lot of the complexity in the language itself, I think a Python 3.5 aware debugger could be pretty good at working with coroutines.
So before we move to the picks, are there any questions that we didn't ask that you think we should have, or anything else that you want to bring up?
Well, just on the subject of the async and await keywords, these are new statements that were introduced in Python 3.5 that make it much nicer to write asynchronous code. It essentially builds coroutines directly into the language instead of being done in a decorator as we've done in Tornado. And because of that, it can actually improve performance by quite a bit. And so I think that for anyone out there who's been on the fence about moving to Python 3, if you're interested in asynchronous programming, I think that these new keywords are a big deal, and I think they're a good reason for anyone who's been waiting to make the switch to Python 3. I think it's a good reason and a good time to come over and give that a try.
And are there any particular areas of the code base or any particular features or bugs that you would particularly like help with?
There's nothing that stands out right now. I think that you can come to our GitHub page and look at the issue tracker and see if there's anything that interests you. There are some modules there that I just haven't ever really used personally. Like, I haven't worked on a Tornado app that was internationalized, and so I don't have any real practical experience with the locale module, for example. And so I think if someone who has done that or has an interest in that area wants to get involved there, that could be a good area to work in. And whether you're actually getting in there and fixing things, or if you're just giving feedback, talking about here are the parts that I use, here's what works and what doesn't, that can be very valuable as well.
Actually, that brings up a point. We originally, as you know, Ben, when we have an idea for an episode every week, we come up with a bunch of questions to ask our guests. And one of the ones we had for you is, what are some of the more interesting and novel applications that you've seen for Tornado? And you expressed that it might be difficult. You didn't really have a good answer for that. And that just sort of speaks to what you just said, I think. I was talking to Tobias about it before the show. There are all kinds of reasons why you might not be able to contribute back to open source. But I personally think that the least you can do, I cannot envision any conditions under which a simple email back to the project, even if it's something as generic as, I work in research, or, I work for the mad scientist whose lair is under a volcano, and we're using this open source project for X, Y, or Z. I can't envision even with the most stringent red tape where that wouldn't be permissible. And I think it's important just to sort of give these people who are kind enough to donate their time and effort to building these things that we all use and love, let them know, give them some love, let them know that their tools and projects are being used. I think that's, if we all want to see open source continue to thrive, we all read about burnout and the like. I think this is one important aspect of it, just simply giving them the feedback and saying, hey, we're using your thing. It's cool. We love it. Here's what we're using it for, to whatever level of detail you can give.
Yeah. I think a lot of times, what I see as the maintainer here is, I hear from people that are having problems, people that have questions or are running into bugs. I don't always hear from people that are using it successfully, and so if you fall into that category where you're kind of the invisible or silent majority, or at least I hope it's a majority of people who are using Tornado successfully and happily, it would definitely be great to hear from people like that, even if you don't have a problem or a question to ask.
So I guess with that, we will move on into the picks. So for my first pick today, I'm going to choose a series of books called The Adventures of Riley. They're kids' books. They're done in cooperation with the World Wildlife Foundation, and they're all stories about a young boy named Riley who has an Uncle Max who's a scientist and takes him on adventures all across the world to study different endangered species. So it's a great way to learn about some of the different animals that are on our planet, some of the challenges that they're facing, and also introduce kids to different areas of the planet. So I've been enjoying reading those with my kids. My next pick is another set of books called the Dayworld Trilogy by Philip Jose Farmer. They're a sci-fi trilogy. They're set in the distant future where humanity, the population of the world, has increased to the point that we can no longer sustain everyone at the same time. And so people are broken up into days of the week that they are released from suspended animation to live their lives. And everyone during the other days of the week has suspended animation pods in the basement of these houses that they all share together. And the most heinous crime in this society is to be what they call a daybreaker, which is somebody who is awake all days of the week. And the main protagonist of the storyline is one such daybreaker. So it's just a very interesting look at overpopulation and, human rights and human freedoms, and, some of the challenges that we are potentially going to face in the future. And it's a little prescient, too, because they were written, I believe, back in the 70s and 80s before our population has increased to the scale that it's at right now. So definitely a fun read, definitely worth checking out. And with that, I will pass it on to you, Chris.
Cool beans. Thanks, Tobias. My first pick is a TV series by Netflix, because they are on fire lately. It's called Sense8, and it is executive produced by J. Michael Straczynski. If there are any old science fiction fans in the audience, they will know that name. He is the dude behind Babylon 5, which is one of my favorite science fiction television programs of all time. It's also directed by the Wachowski brothers of The Matrix fame. It's a really interesting, kind of unusual storyline. The brief one-sentence summary is, people around the globe are having unusual sensations that they can't explain. And it just gets way more interesting from there. It's beautifully photographed. The acting is really good. It's got some really great names and faces that you'll recognize from other places. It's just great fun so far. My next pick is a book. I am usually not all that big on self-help kind of books because I find them mostly to be very repetitive and a lot of kind of pandering. But this one has been an exception. It's called Habits of a Happy Brain, which is kind of a meh title because it sounds like getting to their self-helpy kind of thing. But what's kind of unique about this is this woman who wrote this and basically takes it from the perspective of, this is how your brain evolved. And the evolutionary characteristics that it shares with all other mammals. These are the mechanisms that it evolved for survival in the sort of, animal world. And sometimes those mechanisms can come in really handy in our modern life. Oftentimes they don't. But understanding how they work, like it's a very sort of neurochemical focused outlook on this stuff. Like, if you encounter a situation that might be construed as stressful, your brain releases cortisol, which makes you feel crappy, pensive, like there's something wrong. In the animal world, that could be like, all of a sudden you realize that a lion is stalking nearby. But in modern era, it could be something like, you have a deadline approaching. And so you get that release of that particular brain chemical. And so we all evolve coping behaviors that may or may not be helpful. Like, you might decide to go eat a snack, which you don't really need a snack. You're eating a snack because you're feeling stress. And maybe that's not the wisest thing to do. The book sort of goes on from there. And I just find this sort of functional approach to self-behavior modification to be really fascinating. I don't know how effective it'll be with me, but I'm intrigued at the whole idea. And my last pick is a cryptocurrency. It's a little unusual in the sense that it's not like Bitcoin. Bitcoin is basically almost strictly, exclusively about sending and receiving value from person to person, or address to address, I guess, more accurately. Ethereum is different. Ethereum is a smart currency in that rather than simply having value that like transactions, basically value going from person to person, it allows for smart contracts. For instance, you have a smart contract that encodes these particular gating factors that if the certain things happen, then a certain amount of currency might get awarded to this person or that person. The language that this stuff is written in is a stack-based language, not unlike Forth at the low level, but it has a number of programming interfaces, so you can program it in JavaScript and a number of other things. There's a Python implementation too. I'm just totally intrigued at this idea, and it's being used for everything from sort of prediction marketplaces to blockchain-based democracy efforts to all kinds of other things. It's just really totally fascinating to me. I haven't done anything with it yet, but I'm watching the space very closely because I think this could be a really big deal. And that's it for me. Ben, what kind of picks do you have for us?
All right, so my first pick is a podcast. I don't listen to a lot of technical podcasts, but I really enjoy history and like a show that can tell a story really well. And so my pick is The Memory Palace, which is a podcast of little short stories from generally from American history. They're like I said, they're really short. They're about 5 to 10 minutes each. It's a good one to go back and catch up on the archives if you like this kind of thing. But they're not like about big historical events. They're more about kind of little anecdotes, like the first Ferris wheel in America, or something like that. They're just really well told, and so that's my first pick. Then my next one is an application. So before I was at FriendFeed, I worked at Google on Google Reader, and so my pick here is the app that I use as a replacement for Google Reader now that has been shut down, and it's NewsBlur. This is it's kind of as far as I know, it's a one-man project primarily, although it's open source, and so anyone who's interested can contribute. It's open source and written in Python, but it's got the same similar kind of interface and feature set that Google Reader had, and goes beyond it with some smart features for filtering your feeds to find things you like or hide things you don't like. And so I've been very happy with this ever since Reader went away, and that's it.
So I just want to second The Memory Palace. It's a great podcast. Nate DeMeo is the sort of host, and The stories, some of them are, like you said, just kind of really sort of quaint and really pleasant to listen to, and others will just pull at your heartstrings in the most incredible ways. Like, I don't know if you heard the recent episode about the fire brigade during World War II.
Mm-hmm.
That was just incredible. And the great thing about this is that even if you are just sort of vaguely curious about history but don't necessarily have a lot of time or don't have the sort of intestinal fortitude to sink yourself into a more in-depth podcast like Hardcore History, which I'm a huge fan of, this is ideal because each story is 5 minutes or something in length. They're very short, very concise, and yet you really get a sense for the time and place. He has an incredible way of describing things that's just really worth listening to.
Yep.
All right. So we want to thank you very much for joining us this evening and giving us some of your time to teach us about Tornado.
Yeah, thanks. It's been my pleasure.
For anybody who wants to keep in touch with you or follow what you're up to, what would be the best way for them to do that?
So the best place to keep up with Tornado is probably on our mailing list. It's a Google group linked to from tornadoweb.org.
Well, thank you again. We definitely enjoyed it. It's a very interesting project and definitely one that I'm going to keep a close eye on, and I'm sure I'll probably end up using it pretty soon for my own work.
All right. Thanks very much. It's been good talking to you.
Thank you. Good night.